Our group number is 51. These are my numbers, and our project supervisor is Dr. Bashir Sir, and our co-supervisor is Engineer Habibullah. And these are the contents of our presentation. And our title of presentation FYP is Analysis and Design. Our title of final year project is Analysis and Design of Because Lintel Beam using hollow block. So next, our problem statement is nowadays a problem statement for daily construction. The use of lintel beam is significant. Lintel beams are used above the doors and windows. Normally, the basic problem with the traditional method of construction of lintel beam is the use of formwork, which delay the construction of the project. Which it is also costly because of the formwork. The aims and objectives of our final year project is the main objective of the project is to avoid the use of formwork in construction site and to avoid the delay in construction without compromising on the strength of the beam. Next, please. Introduction. Lintel beam. Now you know it is the definition of the lintel beam. Lintel beam is a type of beam that spans openings such as portals, doors, windows, and firewall. Lintel comes as a beam to support the wall weight and other loads over in opening and to transfer these loads to the adjacent masonry. Lintel beams allow sustaining the structure above the openings such as windows and doors. It takes loading from above and transfer to the bearing column or masonry wall. We use sturdy beams. Sturdy means strong beams to span the doors and windows while on loading. They take bending spaces in the normal space without cracking or bending. These types of beams are used to support the loads exerted by the bricks or blocks. Design reinforced concrete lintel beam to transfer reinforced loading to the adjacent wall. So this is a literature review. Studies have shown that the precast lintels are working in masonry methodology. Now, manual analysis and design. We will analyze the beam. We will analyze and design the hollow lintel block manually and also then check or analysis and design through SAP 2000 software. Data and dimension. The span of lintel beams for the windows is more compared to the doors. So therefore, we will consider maximum total length of 8 feet. We select or cross-section of our lintel beam 9 inch by 9 inch, which is U-shaped, whose thickness are 1 inch and 1.5 inch. Next, please. Selection of section. We have to select such a thickness of a channel which would be able to take its self weight of wet concrete plus the weight of the masonry that will come on it. The channel thickness selected be such that it can be lifted easily by laborers. So now properties of channel. Now inviting my friend Asadullah Khan to continue our project presentation.
Bismillahirrahmanirrahim. I will present the properties of channel. We have two channels. Number one is 1 inch thick channel. So all these properties are from this section. Area and centroidal axis, moment of inertia, and the total mass. Now we are calculated the weights, the self weight, the wet concrete weight, masonry weight, and we sum all the weights to get total weight. And now the load factor for PCC from IBC International Building Code is 1.4. To get the ultimate load, we multiply the factor with the total weight. So this is the ultimate load. Now from analysis, we analyze it by SAP and manually as well. The ultimate moment is 45.6 kips inch, and we calculate the tensile stress in the bottom, which is 760 psi, and also we calculate the capacity, which is 273 psi. It is based on, we take its prime 3000 psi, and also we calculate all the properties for 1.5 inch thick section, which are given. And now I am inviting Mr. Raymond to present.
Thank you, Asad. Sir, actually these are the results and conclusion of what we have done so far. This is not the results and conclusion of our whole FYP project because we haven't done it yet. This is the analysis we done on two kind of sections. One is 1 inch and another section was 1.5 inches. We were actually selecting two sections in order to find out whether they could be lifted easily in the lab, in the field or not. So this is the result and conclusion. First, handling check. Both the channels are not too heavy. That is, they can easily be handled by, because we found the total mass, and from that we concluded that yeah, both of the channels 1.5 inch thick and 1 inch, they both can be lifted easily. So this is okay. Then flexure capacity check. In both cases, flexure demand is greater than the flexure capacity, which we concluded that we have to provide RCC, means we have to provide rebars in our design. So after that, we selected 1.5 inch for our design in order to make sure that the bar we use in the bottom of the section can be adjusted in the 1.5 section. So that is why we have selected 1.5 inch thick channel. We can provide number 1 or number 2 bars easily, and this we already have checked in the market, so they are available as well. And then the shear capacity, we also check the shear capacity. So phi FC prime is greater than VU, so there is no need of the shear reinforcement, but still we will provide some of the reinforcement in order to make sure the shear capacity. And this is our future plan. What we will do in next manual RC design, we will design the lintel beam and then check the design on SEP 2000, and then we are going to do this preparation of the formwork for the U channel, which is something a bit challenging, but we will do inshallah. And then casting of the lintel beam, and after that we will be testing our sample, and then we will be finally give some recommendation on that. Thank you very much. And these are some references.
Thank you, sir.
And